Okay, this is a lesson on solving proportions. 4.4 is the location in the textbook, but this will go with several of the pages in the supplemental packet for Chapter 4. So let's talk about a proportion, exactly what it is. A proportion is when in math we set two equivalent fractions equal to one another. So generically speaking, let's say if we had a fraction a over b and that equaled another fraction c over d, and the equal sign would mean that they are indeed equal. An example would be, and implied here is that if you have a and b, c, and d, that they're four different numbers, but that the value of the fractions would be equal. So for example, let's say we did three eighths, that would equal 6/16, right? So those are equivalent fractions. So what's the point? Well, we really don't worry about setting two fractions equal unless we have two ratios that are equivalent, but you have three of four pieces of information. So that the ratio, so that the information given in the problem would suggest that the ratios are indeed equal, but you're only given three of four pieces of information. And then you can solve the proportion to find the missing piece of information. All right, so let's go to the next page and we'll see how this works. So here's an example of proportion. You have 9 over 15 equals k over 5. And we are going to solve this proportion. There are several ways we can do this. All right. The first way would be to notice that in the first fraction that it is actually an unsimplified fraction, so that we could take 9/15 equals k over 5 and cancel out the common factor of 3, so that this would be 3/5, and now we for sure know what k is. K would have to be 5 if the fractions are going to be equal, right? We're just noticing that if we simplify this fraction, that k would have to equal 3. All right, so method 2 would utilize something called the cross products property method. So when you have two equal fractions, a over b equals c over d, then what this property tells us is will always be true, that when you have two equal fractions, that a times d would equal c times b. So we can use that when we want to solve for an unknown. So if I have 9/15 equals k over 5, then I'm going to say a times d, which would be 9 times 5, equals k times 15. So that gives me 45 equals 15k. I'll do a transformation, multiply by 1/15, and I'll get that k equals 3, just like I did before. And the third and final method that I want to show you is, I call this the multiplier method. Let's rewrite the proportion. 9/15 equals k over 5. And I'm realizing here that in going from 15 to 5 in this direction, that's division by 3. And going from this direction, k would also have to be division by 3. So 9 divided by 3 so k would equal 3 based on that relationship would have to hold, and that will always work that way. Sometimes you'll be multiplying, sometimes you'll be dividing. So those are the three methods you can use. And I'll kind of expect that you could do all three. All right, let's look at the next example. If I have 6/7 equals m over 14, it's a good example of how we could easily use the multiplier method. That was that third method I showed you. Well, we realize here that to get from 7 to 14, that is multiplied by 2. So to get from 6 to m, we would have to multiply by 2 as well. So that m has to equal 12. All right. So you might ask me, do I need to check these? I guess I'm not going to require check, but I think the thing to do, if you wanted to make sure you got it right, that you would look to see that, and that this fraction would simplify. Ways you can know you've got it, see if this fraction simplifies to this one, or do cross products. The cross products here both equal 84, so this is a good solution. Okay, it's best, we most often use proportions in dealing with word problems, so let's do that here. We've got several word problems we're going to be looking at. A boat travels 16 miles in 4 hours and 8 miles in x hours at the same speed. Use a proportion to solve for x. So let's say 16 miles, and I'm just going to write out the units to begin with, and then I'll take them away when I solve it, is to 4 hours, as 8 miles is to x hours. And so you can see on this one, if I just set it up 16 over 4, 8 over x, this time I'm going to notice that this can go down to 4 over 1, that's 8 over x. Going this direction, I multiply by 2, going to multiply by 2 here, and then I get x equals 2 hours. Now, okay, so we're measuring miles on, so measuring miles in the ocean is done in nautical miles. It's different from normal miles on land. And they call those statute miles. Never actually heard that before. In fact, 100 nautical miles equals, so 100 nautical miles is equal to 115 statute miles. So if you're going on, if you plan on going 92 statute miles, how many nautical miles would you travel? So let's use a proportion to solve this. So we'll say 100 nautical miles, I'll just use a little abbreviation, is to 115 statute miles. And we'll set that equal to, got to make sure we have nautical miles here. And you got to make sure you have your statute miles here. We're going to go 92 statute miles, so make sure we get things, and x will be our missing amount of nautical miles. So there's no clear multiplier here. This is probably going to work best with cross multiplying. But one thing I can do here is I can simplify, make the numbers a little easier to work with. So I can cancel out a factor of 5. I've got 25s in 100, and I've got 23 5s in 115, as x is to 92. So just finishing up the work here. This time I'm going to use the cross products property. I'm going to say 92 times 20 would be 1840 equals 23x. And I'd want to divide both sides by, or multiply both sides by 1 over 23. So we're going to end up with 1840 divided by 23. So you might say, how many 25s in 175? I'm going to go with 7 here. 7 times 3 is 1, and 2 to 14 is 16. Actually, I've got one more, so that's going to be 23. So it was actually 8 that was going to come right. It's going to come out evenly. That's good. So I've got 8 times 23 is 4, and 2 to 16 is 18 minus 0. So 80 is going to be my answer. So 80 nautical miles. Is my answer. Okay, I think this is the last problem. So if a typist can type 120 words in 100 seconds, at that rate, how many seconds would it take to type 258 words? So I'm going to have 120 words is to 100 seconds as 258 words is to x seconds. All right, once again, I think don't see a clear multiplier here, so I'm going to go ahead and simplify this fraction over here, this ratio on the left side. It's got a common factor of 20, so that's going to be 6/5 equals 258 over x. I'm going to cross multiply again and get that 6x. I'm going to get that 6x equals 5 times 258. Got to figure out what that is. That's 0, and 4 to 25 is 9, and 2 to 10 is 12, so that's 1,290. And then I'm going to multiply by 1/6 on each side. Which is going to mean 1,290 divided by 6. I've got 2 6s in there. I've got 0, bring down the 9. And I've got 1 6 in 9. And that's 3, so 215. So x is going to equal 215 seconds. And that's the end of the lesson on proportions.